So I'm not the only doctor here. My partner Purna Chandra, he's also a clinical doctor by training, and we are in the health IT space, right? And the talk is about like clinical data integration and analytics using Kafka. So the goal of this talk is I want to like show you what we are doing, what problem exactly we are solving, how we are doing it. We are not sure if it's the right way to do it, but we've kind of arrived at this after a lot of trial and error. So there are a lot of experts here who might have more experience than us, but I would just like to break down what exactly we are doing. And for those who are just getting started with Kafka, for you it might be a potential like, use case on how and what exactly happens and works. So the screen, there is some issue, it just keeps flickering. So maybe just take a photographic memory and then like remember what is on the screen. So this is me in medical school. Now the reason why I switched, so that's me there. So the reason why I switched is that in medical school, most of the time, what can be done by a computer will be done by hand. For example, you had to wake up really early to go copy the medication order of hundreds of patients in the ward. And I learned how to program even as a, like in 10th grade, 11th grade, I knew how to program. But then when I actually tried to make a change in the system and build something for the hospital, it was like almost impossible because each hospital application had its own data, had its own format of data. And then like integrating was the problem. It was not innovation, it was data integration. And how we do data integration is the whole talk today. So since then, I started my own company called Medblocks. Today we serve customers around the world. And if you see the one on the bottom left, that is the government of Andhra Pradesh. And what we did for them was basically, we built them integration with, so all of the hospitals in Andhra Pradesh, we helped them build integrations with this protocol that is released by the Indian government called ABDM or Ayushman Bharat Digital Mission. And today, as of now, there are more than 4 crore patients on just this one deployment in ABDM alone. Again, the main motive in India, at least for moving to digitization, is because like the government literally gives you money. Like if you're a hospital and you enroll a patient in this program like ABDM, they literally give you 20 rupees per patient. So a lot of people now are moving to this, and that's again like if you're a lab facility, diagnostic solution and so on, right? But the problem right now is that this is the approach that most people want you to take, which is like you have an application, you build some extra code in your application to now talk to something like the new protocol released by the government, ABDM, right? Like, so what exactly is this and what does it allow you to do? So you can take your phone and you can download these apps. There are hundreds of apps. It's just like UPI in a sense, but you will be able to pull your health records from any hospital that you visited. And other hospitals will be able to request data from any other hospital you visited, and you can consent and the data goes through. So that's basically what ABDM is and what they're trying to do. Now, as a company, we've tried to integrate with multiple applications, and what we learned is that there are a few challenges, and things are, can I do something about the screen? About flickering. Not sure where the loose connection is.
No, it's okay.
It's okay?
Yeah.
Okay. So just give me a second. Yeah. Now, this is hard for multiple reasons, right? Like one is every application has its own representation of the data, right? So every single hospital we go to, someone will be like, we are storing data in Excel. We are using Google Sheets. We are using, we are using this old Microsoft Access database from 19, God knows what. And custom development of APIs for every single application and going and looking at their exact implementation is very expensive, slow, and just like risky, because this is a system that's running, and if we break it, then they can't do normal patient stuff, right? So touching that code base is like asking for trouble. And the other thing is like many of these are extremely legacy applications. The developer need not be available, and sometimes the developer is like outright dead. So there is literally no one we can go to who knows what the application exactly does. And sometimes this is like compiled code just running. We have no idea except for the database that it's using. So what we came up with was, okay, instead of tapping into every single application, like these are hundreds of applications across multiple hospitals, instead of going and changing the code there, it's easier to get access to the database that the application is using. And if we can get access to the database and convert it to a standardized format, in this case, there is a format called HL7FIRE, which stands for Fast Health Interoperability Resources. And we thought if we are able to convert it to this particular standard, then we just need to build this app once, like the Medblocks ABDM application. We can build it on top of this particular HL7FIRE API standard and that data format. So that's basically what we did. Like we initially developed that on top of the FIRE format. But the problem is each hospital we go to, each setting that we go to still had their own database, right? Some were using really old stuff, but some were using relatively modern stuff like Postgres, MySQL, MongoDB. We've seen all of this in the wild. Now, this is a hard problem, okay? And I'll tell you why this is still hard. So we need this data to be as real-time as possible. So as soon as the patient enters into the system, we want that data to be available on the network so that, for example, they can then pull the data from other hospitals and they can communicate with the network and get all of your history, for example, in time. So the time we have is less than, you go and register at the desk before you kind of go into the next station, which will usually be like a nurse or it might be a hospital. We want to like make sure it's all ready and we pull the information and it's all kept up to date. So it's almost real time, right? And it's again like impossible to ask the application developer to make changes, especially if they're dead. And it's impossible to make or request database level changes as well. Like we can't ask them to change the schema. We can't ask them to do anything that will require significant changes at the database level. So we are kind of like at this level where we know what's going on, we know where the data is, but you can't really touch anything. Like you can't really do anything, right? It's kind of like, and again, this is a live system. So the system is running. They are serving thousands or like 10,000s of patients a day, some even, and you need to make sure that this data is now present in this other database. It's kind of like refueling a flight mid-air, right? Like if any of this breaks, you are at a risk of losing data. You're at a risk of just like disruption of service for that healthcare system. Now we considered two approaches. Like one was batch ETL and the other is like real time. So batch ETL, what you can do is you just look at the database, you write some SQL queries, you're able to like pull all the database data, and then you do this transformation once every single, like let's say 24 hours or 4 hours or 6 hours. You do it hourly or you have some sort of a time lag, it's slow. And the other problem is we noticed that it was also expensive, not in terms of money, but in terms of what we are hitting the database with. So every single time you hit the database with like, give me all your data, that is equivalent to the doctor calling us and being like, why is my system slow? Why is it not working, right? So, whereas on the real-time side, again, like we were using a more traditional real-time approach before. So for example, there is no time lag, but the way we did real-time was that we wanted the application to directly change something so that it is able to either send a webhook or it's able to send data to an event broker in some way, right? And this is usually what people think of when they think, okay, how do I integrate this application? Like I have an application, it's already talking to a database, now it needs to push data to another format. The simplest solution you think might just be, again, like this is the ETL process, it's slow, it's time consuming, you have this process that runs. Now, the usual simplest solution, which is like the Occam's razor solution would be, you make the application send data to two places at once. right? It sends it to the database, but it also sends it to this HL7 Fire data format, this other data format we need. But this is really bad for a lot of reasons, right? The main issue is that there is this thing called the dual write problem, okay? So if you do this, and if you're doing this for any other services in production, or you are doing this in any sense, it will hit you at some point, right? So the problem is that if things can go wrong, it will go wrong, right? And if the application is able to, let's say, write to the database, but then for some reason you are not able to communicate to the Fire server in this case, you have this inconsistency immediately. So you've committed the data to the database, but then the data is not present in this server, right? The same thing the other way around can also happen, that the Fire API request is valid and it is cool, but the data is not present in the database, right? So this is the dual write problem when the application tries to commit data to two places at once, and it's a very hard problem to solve. Some people might think, okay, what about, can my application directly push data to an event broker, like Kafka, right? And you have the same problem again. What if the database transaction goes through, but then your application, right before it thinks that it needs to push data to Kafka, the server crashes, right? So it's just inevitable that if you implement something like this, and again, you can't have high availability, you can't do anything about this, because even if you run multiple replicas of your application, one instance of your application is committing data to the database. Right after it commits, if that server crashes, what are you going to do, right? So this is not a real solution either. And again, there's a dual write inconsistency problem. It's unreliable. It's also kind of hard to implement correctly, because you need the application person to understand what data to push and where and so on, right? So again, there is this great resource called microservices.io where you can see what kind of patterns they're using to solve these kind of problems. So one of this is maintaining data consistency. There are a few approaches to this. So there is the Saga pattern, there is event sourcing, there is aggregating things, and there's a lot of these patterns. But many of these are really hard to implement. So today I'm just going to tell you what we do, how we do it, and maybe might help you in some way. Right? So again, batch ETL has these problems, real-time has these problems. Initially what we used to do was we did batch ETL to start off with. So when we started a project and there was a lot of legacy data, we did batch ETL to move that, and then we would start the real-time as soon as that legacy thing is done, right? But this came with its own set of challenges, right? First is the ETL process was slow and expensive. You have to write code separately for that. Then the real-time phase was unreliable, it was inconsistent, and you had the dependency on this application, and the implementation also happened twice. You write code separately for the batch ETL, you write code separately for the real-time aspect. Now, how many of you have heard of change data capture? Okay, not bad. Not the majority, but okay. So change data capture is a technique where you directly listen to database events in real time and stream those changes to an event broker. Okay, this could be Kafka, but it could be other event brokers as well. Now, we were using change data capture to now directly tap into the database and listen to what changes are happening, and then push that to an event broker, and then transform that and then push it to a Firestore. Seems like an easy solution, but then it also comes with its own set of problems and complications, right? So again, we use this tool called Dependency. It's a really cool tool. You need to check it out because it has source connectors for almost all popularly used databases. So Dependency, it can work with MongoDB, MySQL, MariaDB, Oracle. It just covers a lot of these databases. You're able to capture data as it is happening. So what Dependency does is it initially has a snapshot phase where it scans the whole database table. It captures all of them as events in a Kafka topic. Okay, so if you have one table, it will capture all of the data in that table in that particular Kafka table topic. And as the changes happen to this particular database table, it will stream the changes in real time to the event broker. So the way it usually works is it uses the same protocol that databases use for database replication. So in case of Postgres, it will be something like the write-ahead log. In case of MySQL, it will be like the, it's called the bin log or the syslog, basically. Bin, yeah. So, and I think in MongoDB, it has, what is it? Outbox. Yes, Outbox. So you only need to make a configuration change in the database to kind of enable this approach. You make a configuration change, you're good to go, you're able to just like connect to the database, and it's the same protocol as the replication protocol. So it's like well studied, well understood. People know what it means and how this works. So you get a copy of this data in your event broker. Then what we do is we need to process this so that it's in the format that we need in the Firestore, in that particular format. So you need to transform this data. Now, once you transform this, we are talking about like topic to topic transformation. Like it comes in one topic, you need to join like 5-6 different tables to make sure that the data you need is present in a particular format. Then you output it to another topic which has the desired format. After you do that, all you need to do is like push it to the Firestore, right? But again, it's not as easy as it seems. Okay, so the advantage here is that it's a single implementation. You don't need to write mapping code twice, which is like very expensive. If you have to write one separate ETL process and one separate real-time process, there is no dependency on the application. It's like pretty real-time. The tooling is decent, but it leaves a lot to be desired. So there are still a few edge cases. And again, it's like quite reliable. We've done this a lot right now, and it's quite reliable. We are happy with what is there. But again, the stream processing is quite complex. And the database support for logical replication, there are some databases that still don't support this. One good example is like SQLite, which is some people use SQLite in production. And you can't do anything there. But so how do we exactly do this?
In this slide, you have just put the cross. What do you mean by database support for logical, not database support for logical? Most of the database is having the logical replication support.
SQLite. So here again, like what exactly we do, how the process exactly works. We have all our deployments on Kubernetes so that we can, just to move between cloud vendors quickly. So some of our customers will be using AWS, some will be on GCP, some will be on Azure, some will have on-prem servers. We don't want to change our deployment code depending on where they are. So Kubernetes for us is more of a abstraction around how we deploy rather than anything else. We don't really care about like other things. There are other ways to deploy this as well. But for us, we use Kubernetes with the strimzy operator to deploy Kafka, to deploy the Kafka Connect clusters, all of that. And Debezium also is a Kafka Connect instance. So we deploy Debezium there. It connects to the database, it listens to these changes real time, and it pushes it to the topics. Now, our developers are able to visualize the topics using a tool called, I think it's just called UI for Kafka. So there is a tool called UI for Kafka, and it's a web app. They go there and then they just check, okay, is all the data here, right? From UI for Kafka, they actually do a CSV dump of all the data just to see how the data looks like, because we need to now then sit down and do the mapping between the data we have versus the data we need, right? For example, I've kind of blocked out the most occurring values because it's like sensitive information. But it's like the domain data model of that particular database. We have to take it and convert it to this standard FHIR format. So we have to map it to, okay, where in the patient ID does this map to and so on, according to that particular standard. After we do that, we need to transform, okay, like we need to transform this data actually and write some code. So we do this using a combination of Kafka streams and KSQL DB depending on the use case. So what we noticed is KSQL DB is good for just simple operations most of the time. Like if you just want to join a few tables, if you want to do some sort of stream join or stream table join, or these kind of operations are simple in just using KSQL DB. But as soon as you get to domain level modeling, so you want to convert this data to a very specific format with conditional logic and so on, it's harder to do using KSQL than just like write the code in Java and use something like Kafka streams. So we do a combination of this, but in most situations, if we have a Kafka streams deployment, we don't use KSQL. The Kafka streams deployment takes care of it for you. And now it's important that, again, like for those who are just starting off with Kafka, please understand partitions and parallelism in Kafka and what partitions are and how it works. Not knowing will just fuck you over in the long term. Okay, so here it's important that, so Kafka kind of acts like there are multiple topics, right? And inside each topic there is a partition, and the way you can parallelize operations, especially for us, the parallelization is important to push data into the Fire server in parallel as quickly as possible. So in that case, what you want is the Fire server kind of needs to know which patient you are talking about first, and then you talk about like the visit, because the visit references the patient. And then you say you have a diagnosis for this patient. That diagnosis will reference that visit. So if you push things out of order, so if you push the diagnosis in the event topic first, and then you have the patient, and then you try to push it to the standard Fire server, what will happen is that it will error out. Like it will be like, what are you talking about? This diagnosis, this patient doesn't exist, what is this, right? So it's just, think of it like a relational table, but if you try to push something into a relational table without the dependency of that foreign key, it's gonna error out, right? So that's it. So you have this need to organize these dependent resources in order, okay? Now, seems like a simple problem, right? Like it should be simple to just like sort this, but you are doing a real-time stream. So if you're sorting, you kind of need a time window. Like in which time window are you going to sort? So initially we were like doing something around time windows, and we were like, okay, the snapshot phase happens, and then we do some sort of a time stamping and watermarking, and we sort it. But then we are like, the simplest solution is, while setting up Debezium from the database, you include the tables incrementally. Like you initially just start including the patients only, and once it's in Kafka, then you start including the visits, then you start including the diagnosis. That way, the data in Kafka by nature is in the order in which they depend on. And then the real-time data, once it starts coming in from the database, it's going to be in this order anyway. Like the visit for a patient is not going to be created before the patient, right? That happens sometimes if you have some things out of sync, but that time window is much lesser. Like you can just have that time window at like, let's say 10 seconds or something. Whereas doing it the first time with the bulk migration is just a nightmare. So anyone who's doing this, this is what we've learned, like do not try to sort it on like an infinite time span. It's very inefficient, it doesn't work well, okay? Second, I mean, we are at the fourth slide, step 4, we deploy it, right? And like the challenges we face and what really happens. So when you have these massive table joins, you're going to have insane use of memory, right? Like, so when Kafka streams or KSQL does these table joins, for each table it needs to create an entry in memory, and it basically has to know like, oh, I have a stream of these tables from this topics, and I have a stream of this from this topics. Then I need to look at these foreign keys and merge them into this virtual table, okay? Now, what we noticed was, using this much memory, first of all, does not make sense, because we are not like, it's okay if it's 2-3 seconds slow. We could make the trade-off between speed versus memory usage. So instead, what we opted to do was, you can have most of this data in your hard disk instead of your RAM, okay? So it's possible to put all of this in your hard disk using just like there are some configuration properties you can use for RocksDB in Kafka streams to just say like, go crazy. Like we'll give you a 250 GB hard disk, just go crazy, don't use like 48 GBs of RAM, okay? So initially the snapshot and the mapping process is very intensive still. It's still memory intensive and still storage intensive. But once the initial part is done, like you have this backlog of all of this data, you kind of transform that, you do all the table joins. What we do is, again, storage is much cheaper than memory, okay? Just in any cloud vendor, it's going to be like 100x cheaper. So it just makes sense to use a hard disk to mount it to some volume instead of putting that in RAM, okay? Okay, here I wanted to say something else as well, which is, yeah, you want to, after the initial deployment is done and after you have the initial part of your data mapped, we usually do a rolling update to reduce the consumption of resources. Because the real time, you kind of know it's like a trickle, right? If you want to visualize it, it's kind of like, think of a bucket full of water that has been collecting for, let's say, an hour or two. You need to now process this bucket, but after you process this bucket, it's going to be a trickle, right? It's just going to be the new data that's coming in. So it makes sense to allocate resources according to this. You know that the processing of that bucket is going to require more RAM, more CPU, more storage. Give it that high amount of CPU, RAM, and so on. But after that initial phase is done, you're monitoring and you're like, oh, it's fine. It's now in the trickle phase. Scale it down. Do a rolling deployment, deploy at least like 2-3 instances of this Kafka Streams app, and scale it down, bring down the CPU usage, bring down the memory usage. You can also clear the cache because you're not going to see those records again for the new real-time data that's going to flow in. Yeah, then you have the sync connector. Finally, like from, you have the data in the processed topic. All you need to do is like push data to the data store that's required in that particular format. Now, you can write your own Kafka sync connector. It's not that hard. It's just a little bit of Java programming, and you are able to package this into the Kafka Connect instance. You can do this. Some things to keep in mind. So you need to make sure that you succeed or fail atomically on a particular batch of records, okay? So you don't want to mark something as done if you are not actually done on that. So it's important to maintain this one-time guarantee. Like if you just want data to be present once and pushed. So here again, like we use the partitions for parallelism. So each partition will get its own sync connector. Anyone worked with Kafka Connect here? So you know the concept of tasks, and so each one task per partition basically, and you are able to push all of this simultaneously in parallel. Now error handling has been like implemented. It's kind of recent, not too recent, but then your Kafka Connect plugin can actually understand if a particular record errors out, and you can report that error. Now these errored records can be stored in an error topic, and it's configurable in Kafka Connect. So there are going to be errors, like there are going to be some things that are just going to fail. So in that case, you want to like take those and then put this in another Kafka topic to then look at and process later. You don't want to completely stop everything. So you carry on with life as normal, but then these errors, you just like store them and you look at them later. Sometimes it's just the application developer being like, they store like a string in place of a number or something. It just happens. Okay, there's nothing we can do about it. Now, once you have this data here, right? Like once you have it, it's kind of like moving from a dumb phone to a smartphone. Like because the data, once it's available in this standardized format, this is what we've been advocating at Medblocks. This is what we do. This is what we our vision is, which is you have multiple apps that can then run on this data. And again, like there is an app store for healthcare today, and what this does is like on top of this standardized data, it can, that's a, how to monitor your baby's parameters, certain parameters. This is for diabetes management. This is for, chief complaints and what exactly the patient has. There are hundreds of apps out there, but they can only work if the data is in that format that they're expecting. They're not going to work with this local hospital's Word document, okay? So once we have that, we are able to do this, and just as another consequence, since our apps are able to, that ABDM app that we built happens to be one such app. So we are able to connect people to the Ayushman Bharat digital mission, and they're able to get the benefits of sharing the data, consenting for the data, sharing it between hospitals, and getting that 20 rupees per patient per hospital. So I think I'm early. So that's it. If you have any questions, or we can discuss. They're again a small team based out of Bangalore. We always have requirements for data engineers on and off, even on a contracting basis. So if any of you are interested, you can reach out to me. Either you can join the team. We can work with you on certain contract assignments. We are definitely looking for people who know Kafka, who know the nuances, and are able to. I know maybe certain things we did, maybe we can do better. I would like to hear from you. So any questions, feedback, what do you think of this approach? I would like to know. Yep.
Are you building, so the transformation of the data from the source to the destination,
Yep.
it is going to vary for each application?
Yeah, it's going to vary for each.
So are you building a different connector for each hospital?
The connector, we are not building it differently, but when somebody is going to write, so the Fire sync connector stays the same, because we are transforming it into that format finally, and it's going to push it to that thing. The streams processing is going to be different. That's why we need contractors, and we need people always working on that.
There will be so many hospitals.
Yes.
How are you going to scale over a long period of time?
It's like either our bet is that people will start capturing data in the standard format to begin with, but people don't do that. So for the legacy data, we need to write some code to convert it. Maybe AI will make this easier, I don't know. But like the scalable solution right now is at least do not touch the application. Like if you're able to do it with the database, we found it to be significantly easier than talking to the application developers and grabbing them and then finding out what this is. So that itself, I would say, is one leap. But beyond that, that work has to be done. Like someone has to do that.
Not directly on the code part, but potentially if the hospital changes the schema, right?
Yep.
So like, what is the contract with your company to understand, because you guys would need to pre-plan a lot of things on that.
Right. It's a really, really good question. So there is a part of Kafka Connect which also listens to schema changes, and it outputs it in a particular topic. So we have like for certain people, we've set like an alarm bell or like an alert in case they change the schema. Alert everyone. Red alert, like stop doing this. Like the problem is most of the time the applications we are working with are not like startups pushing features. They are the opposite. yeah. So that database schema, if it changes, it will be like a once in a blue moon. Like, we'll also be surprised sometimes. Like, oh, you're changing your schema, okay, fine. But it's a very rare occurrence. But for people who are actively developing, then we have a little bit more tighter engagement with them, and we usually tell the developers like, please.
And because broker can handle the weighted part too, definitely we can say that if there is a schema change, we wouldn't process the entries that are coming after that, and then only after we know the new ETL we will be pushing.
Yeah, exactly. And this is actually a very, very good advantage of using something like Kafka. So what we noticed is that storage is cheap. Like storage is dirt cheap, right? So we sometimes store all the messages on the event broker indefinitely. And we're just like, okay, the transformation went wrong, something went wrong. The fire store is now not correct. We will like delete the fire store, start from scratch, do it again, right? It doesn't take that much effort to do that because all the data is like, it's there, we have it stored. So even if they make a database change or the script that they did makes it's wrong, we just clear the fire store out completely and we start from scratch, which is it's not something you can do with like ActiveMQ or RabbitMQ or like other things.
Do you handle like duplicate data and things like that?
Oh, very good question. Yes. So duplicate data. many times you need to be able to handle more than once the same record like showing up. So we make sure that the Fire sync connector is idempotent. Okay, idempotency for those, like, okay. So let's say you press a button and there is an on and off switch, and pressing the on switch multiple times will still keep it on. So what you want to do is have a function which no matter how many times it executes, its effect is the same. So for example, when we are creating a Fire patient record, we will not post it. We'll make a put request with a particular ID, so that even if we run that operation multiple times, the result is the same. So that's a very good.
It is like a transaction ID. For particular transaction ID, it will not be making the same changes.
Yes, exactly. And even if we make the same changes, it's fine. Like, it's okay. Yes.
One more thing, actually, what is the problem if you, as you will be having some contract with the hospital to get the data from Dependency, right, with the help of Dependency?
Yes.
So my question is, why don't we, how application is sending data to the database? What is the problem that if two things go in parallel, so what are the challenges there?
Yeah.
Because what I'm thinking, you will be having a different database every in different hospitals.
Yes.
Right?
Yes.
They will have different schema also.
Yes.
Right? Why don't we have a thing from there? You get the data and according to your structure, you pull the data and just store it.
So you're talking about being able to, the application to be able to push data directly.
Yeah, correct.
Right.
Or maybe you can have some kind of a parallel application or process which will be sending data. I mean, how you're storing to the database, before storing to the database, you transform and...
Yeah, put it in this other thing, right?
Yeah.
Okay. So what happens here is that we've done this. So let's say you have the same application, right? Like you're writing code, and then there is a line in one code which says like put to database. And then there is a line before that which is like transform and store in Fire database. So the application is running all good, right? So it comes to the line where it's like transform and store in Fire database. Succeeds. It comes to the next line. The server crashes. So now you don't have the data in the database. That's the dual write problem basically. So if you have a line of code which is non-transactional, which is like it needs to happen one after another, then there is no way to work around the fact that one might succeed but the other may not. There is no way to make sure that it either succeeds together or fails together. There is one way in which what you're saying makes life easier for us, and that's the approach is called transactional outbox. So what they do is while committing data to the database, at the same time within the same SQL transaction, they commit to another table in a format that is easier for us. So they do the joins and they take the data in the format that we kind of need, and they commit to that table along with the main table. So this is good for us because we can then listen to the database transactional outbox only, and we don't need to do the joins later on. But it's still important that the transactional outbox, you need to create the data in your outbox and in your main database in the same transaction. Either fail together or succeed together. If you don't do that, inconsistency.
And there's a problem for them because first thing they will need to change the code.
Yeah.
Second thing,
Yes.
their failure rate will increase.
Correct. It's a huge risk. That's the other thing. Like whenever we are thinking of application level changes, we are just like, because it might fail. Like they do something breaks, and we don't want that on our heads. So that's one approach though. Transactional outbox is a very popular, common approach. Yeah.
So you're saying that in both the cases, there are chances that server might crash.
Yep.
So there is absolutely chance that you will be losing data.
Yep.
In either of the scenarios.
If you're doing dual writes, yes. If you're doing dual writes, there is a chance that you might lose.
The application is writing to database, and then there is also chance to actually server to be getting failed. So why don't you do the
No, it's
replication?
what?
Why can't we do database level replication instead of application writing to the two databases?
Yeah, exactly. That's what you're doing here. So when we say we are doing like Debezium and so on, it's using the same replication protocol. So we are doing that same thing. So here, to come back to your question, so your question is basically, there is a chance that data loss might happen regardless of whatever we do.
Right. So is that the case, or you are sure that if application will always write to database?
The application failing at the database level is not our problem. So okay, if there is a validation error or some constraint error and it fails, it's an application level concern. We are like, okay, let it fail, it's fine. But they will see an error in their UI, they'll know what to do. But if it succeeds in the database, we fail, they'll think that is okay, but it's not okay on our side. That's, inconsistency is more of an issue here.
Okay, so on the CDC part, like from the database to the Kafka, so if that communication fails, so Debezium handles that part. Like if it is not able to send the changes first, it will keep the changes with itself, and then later it will be able to send.
So kind of retention.
So retention it has. So because of that failure, so if the changes are in the database and we have the Debezium available there, we are not worried that from the database it wouldn't go further because the retention is not.
It's also the problem of the ownership then, right? If their database works and then if writing to event broker fails, they would still be like okay with it, like because their thing is fine.
Correct. That's another good one.
Application logic is Kafka stream. So application level logic.
When you mean by application, who's asking? Oh, okay. Yeah.
So actually the application will do some logic and put it in the database.
Correct.
So the database will collect the data, this Kafka streams, and transform the data and then put it in the file stream.
Correct.
The transformation needs some logic performed
Yes.
in the database.
Yes.
Can we also include some application logic inside this application?
So when you say application logic, I'm a little scared. So transformation logic for sure. Like we do the transformation. We look at topics in Kafka. We need to join or do some transformation into the standard that we want. When you mean application level logic, what do you mean?
Kind of, let's say we have a script to do some automation, or we have some logic written in, like, let's say in AWS Lambda, it will run individually a function. Like,
Okay.
do some task.
Okay.
So the same kind of thing, can we do it in Kafka stream? There's some a particular task.
Yes, you can do it, but you can do it. There's nothing stopping you from doing that. However, a slightly better pattern would be if you're able to transform the data into the format that your function needs, and then finally process that topic. You will always have a log of like, okay, the transformation worked fine, now it's in this topic, and then you're reading this topic, or let's say you're sending emails, simple example. Then the application that looks at this Kafka topic to read emails and sends emails, its only job is to read and send emails. It doesn't need to do the transformation, unread and send the emails. Because later on, you may want to just like KSQL is easier to do, or maybe Flink comes along and we want to replace the transformation logic with Flink. You have the opportunity to change. So best to separate those things.
So this thing happens in the same as Kafka itself?
No. The way Kafka stream works is it's just another Java application. It runs in the JVM. It just happens to use the Kafka wire protocol, but it does all of the storing, and it's its own application. Kafka has nothing to do with Kafka streams. So
It comes before Kafka broker or
after. So the event gets created in a topic in the Kafka broker. Then this stream application happens to be one listener of this particular event. Kafka has some term for listener. It's consumer. Yeah, it happens to be one consumer, and it does its processing and so on. And it just happens to be another. It writes back to another topic if it wants. It can do your work like sending emails if it wants. Can do whatever.
You said the ordering, right?
Yeah.
Sequencing or ordering.
Yes.
We can do it Debezium level, right? That's
Yes.
Now, with that approach, sometimes your Debezium, you do pause or event reading process, error out, you create new one and so on, right?
Yep.
So in that case, again, so Debezium allows you to specifically define the ordering sequencing, or
No.
it's something on the create time only?
It's something on the create time that engineer has to be like, first finish this and
That will go on changing if you have to recreate and delete the older one?
Yeah, but the initial setup we only do once, right? Like when we are initially going to that hospital and we know that they have these many tables.
Day one I maintained that.
Yeah.
Day 20, some issue happened.
Yeah.
And I have to recreate.
Oh, yeah.
Recreate the entire thing versus
Yeah.
problem.
You have to.
There's no way of changing sequencing later.
See, when you say.
Internally via hooking up.
See, when you say problem one, let's say that we didn't create something like the patient record correctly. That a lot of other things depend on that.
Day 1 all good.
Okay.
Day 5 all good.
Okay.
Day 20 something happened.
Yeah.
Bloaten up or some problem.
Okay.
Now because of that day 20 issue, I have to just recreate.
Recreate what?
The Dependency source connector itself.
Okay.
Where this sequencing has happened on the day 1.
Oh, right.
Now in between that sequencing, I have to delete the third one because error out.
Okay.
Now this dependency failure will be there because I have to recreate the later stage, or if I have to troubleshoot that and pause that.
Right.
So, that will be,
So usually.
we can hook up internally, play with this and make that sequencing again.
Right. I understand this question. The way we do it, at least personally, is that once that change data capture happens in that particular order, we do not touch that topics. Those topics are like, in case sometimes there is they have custom types in Postgres and so on. Then you have to write custom converters and this SMT level transformation, something is there. So this may be wrong and you may need to redo it again. But then we redo it until we get it right. So you delete the entire thing and do it from scratch from the database. Because the data is there in the database anyway, like it's not going anywhere.
So what is the expectation on SLOs? Like let's say a data has been posted from the application. When is it expected for the other applications which are built on top of it to be file to be available for consumption?
Oh, good question. So it depends. See, the thing is, for something like ABDM, it's not a big deal. Like this, it's okay if it's like 1 or 2 hours late. But there are a few other applications like real-time analytics. We want to send lab reports and we want to send, so those things are more sensitive to time. So we try to keep it below 2 seconds.
Okay. So how many partitions do you have per topic?
So around 10 is our standard that we take for a normal hospital. But it again, like if it's much bigger, it depends on the scale of the setup.
Purely on the scale.
Purely.
Your need of scale.
Yeah, you need of scale. But the thing is, we deal with, when you think of a hospital, it's not that big. Like
Are
okay.
you ensuring that all patient data goes to the same partition, or how are you managing?
No. All patient data, okay. The data of that single patient will always be in that same partition. So because you need this ordering guarantee, right? But different patients will be in different partitions. We basically partition based on patient.
Kafka is the order maintains only in the partition, across partitions it does not. If it goes to different, then it's screwed.
Yeah. So for that patient, it needs to be in that same partition.
So a use case kind of, let's say for example, end user perspective, same name, patient, comes with the same, similar age.
Yep.
You just go to different consider the same concept.
No. So can you repeat that again?
Same age, same name of the patient.
Okay.
2 different patients, but same name,
Yeah.
same age group.
Yeah.
Okay. And access the same consultancy doctor.
Yep.
How do you handle that kind of situation?
So that is application level concern. Application is responsible for creating a unique ID for each patient. If they usually have these duplicate record matching, it's EMPI, it's like Enterprise Master Patient Index and all. They have a lot of these other tools. When it comes to the database, if it has a unique ID, we consider it a unique patient. And we use that for the partitioning key. If they are different, the application has to handle that. Doing it on our side is like a little, yeah.
And this can be also accessible by the pharma industry?
By the pharma industry?
Yeah.
Yeah, sure. It's the same logic. It's, this data you're asking.
Yeah.
ABDM allows anyone to access it if you're registered with their network. So pharma, even research facilities can all access this data if the patient gives the consent. So you can request the data from the patient, and the patient, if they grant that consent, all of their data from all of these hospitals will go to the concerned thing.
One question
Yeah. Yeah.
Yeah, so the initial load on your whole infrastructure is high when you onboard an hospital.
Correct.
So after that, the PDC, the change data for a particular patient, how often does it get updated in the application side?
Depends on the volume of the hospital and what exactly they do, but it's nowhere close to the initial load that we get. It's nowhere close. Like this will be 10 lakh patients, and then per day you get like 200, 300 patients a day. Depends on the walk-ins and the appointments, the remote patient calls and so on.
So how do you handle the load on the infrastructure side when you onboard a hospital where you need more compute?
Yep.
Right, compared to one on a regular basis, on a daily basis. How
Yeah.
do you manage that?
Okay, I'll get into the nitty-gritty details in a little. So we host it like, let's say on Kubernetes, right? Let's say with a cloud provider, Google Cloud. So what we do is when we are onboarding, we know that this is going to require a certain amount of memory. So we'll add one high memory node, we'll add one high vCPU count node, let's say one 64 GB RAM, one 8 vCPU node. We'll add that. The containers for Kafka, we will set the requests for memory and CPU high enough that it can do this. It just increases. We know that it will go till 116 or something, and then it will plateau at that. After that, it is just storing data in the RocksDB. So we also give it a volume. So we give it enough volume on the temp directory so that it is able to use that also significantly, like nicely. Then after the initial phase is done, we again, like let's say this only takes like 8 hours or something, like even for the biggest hospitals, it will take some time. So the high capacity node, I don't need it anymore. I scale down the deployment of Kafka streams and set the requests to be lower. And then I completely remove this node altogether from the infrastructure. It will usually schedule on some other node.
Okay, so all this you do manually?
Yeah. No, it's like someone manually seeing and doing this automatically is like hundreds of things that can go wrong. So, yeah.
Actually, let's cover, like, when will you say it's done? Like, why do you really need to have that trickling data coming in? So
We constantly, firstly, we look at the data that's available in the Fire server. We know like how many data points are there and how many. So there will be a point, usually this happens very late at night, where we hit that point where all of the data right now has been processed. We need to wait for the next patient to walk in the morning. When that happens, we are like trickle time.
Better reconciliation kind of
Correct.
better report and then set done. And then
Yeah, we look at it manually. We just look at the thing manually, and when it's done, we remove that node. We are not paying for that anymore, and like.
even the application that can work with your migrated data, right? So even the application goes DB goes. So you provide new application which will give that same format, and then you continue with the new application so that you can have.
Correct. Yeah. So I mean, once the data is in this format, then many of our applications work. Many of our partners' applications that they've developed internationally, all of them work. So yeah. So usually they don't get rid of the original application. It's still it's there. But yeah, that's the other reason why we need it real time. Because if you're running these other applications, like the data that's coming in this one needs to show.
So what is this Elysium phase?
What is the?
Elysium phase to trigger new database changes to the
Debezium has been one reliable machine for, like it has a lot of fail-safes. Okay, so yeah, I mean nodes can crash, things can go down, but what happens is that it stores the offset of until what point it has read some in the wall log. So it will resume from that. Yeah, so it has a checkpoint and it will resume from that wall log. There are things where sometimes Postgres itself like overruns and it deletes those wall logs before Debezium can consume them. But those are like very silly mistakes to make, but we made them. So if that is properly configured, then this issue won't usually happen. You just run multiple instances of everything. So one is like Debezium, even the Kafka Connect version of Debezium, you usually run it in high availability. So you run it on, let's say, in a cloud provider, they have these things called availability zones, AZs, and they ensure that each AZ has its own internet connection, its own electricity, its own like whatever. So all the availability zones going down at once is very rare. So if you host the nodes of the Kubernetes cluster in each availability zone, the whole thing going down is very low. But if in case it goes down also, the data is stored in disk. Like the checkpoint data is stored in disk. The database is going to be either on-prem or it's going to be stored in disk. So when it comes up and it resumes.
So do you replicate this whole infrastructure for each of your customers?
Replicate, yeah. We don't have a central one cloud where we do all of this.
Scalable, man. So it is not scalable, right? Because multiple customers have some majority of these medicals, I mean, the hospitals, a majority of the SaaS-based applications. So how do you handle that kind of situation? Because SaaS-based, they use their own databases in somewhere in the, either on-prem or somewhere in the public cloud space.
Yeah. So let's say it's a SaaS solution. They are. So the question is?
I mean, how do you handle that kind of situation data if everyone has their own form? Multiple hospitals use multiple SaaS-based applications.
Correct. It's not scalable.
Operations management.
It's not scalable. That's why we are telling people to use this format. We're telling them like don't invent your own thing. Like we are tired of converting it already. Like just stop. Get help.
Second bit is regulation. We can't take data out without patient's consent.
Absolutely.
Yeah. So sadly, we have to host and that there is a cost associated. So everyone has their own Kafka after conversion, and we keep it in there.
Yeah, that's also why we haven't really gone with the Confluent platform, because it's a small scale deployment most of the time. It's a lot of small scale deployments as opposed to one really huge infrastructure.
What if the hospital is already using the format that they are expected to run?
I haven't seen even one. It's like but if they are using that, then we don't need to do any of this. Our ABDM application will run directly on that.
But do the hospitals come after you have onboarded them into your infrastructure, right? After a certain point in time, they start generating the data in the format that you want?
It's because we've put in the time and cost to actually do that transformation for them, and it's running real time. So they're like, what is our incentive to now, like so.
Just to check, you mentioned lab reports has to be on host in 2 seconds, right? Have you ever faced state restoration issues with your system?
Regulatory issues in India, no.
No, state restoration. State restoration.
State restoration.
Yeah, because you are saying everything in the ROS DB locally. Right?
Correct.
So let's say if something goes wrong with the box.
Correct.
Sheet, right?
Correct.
If a new box, it has to come back.
Correct.
The state has to retrieve again from the broker. That's a state restoration, right? Did you get into that situation anytime?
So we've had node failures, but then the PVC or the volume that we usually use to store the state of RocksDB is usually intact even if the node goes down.
So that means you are storing that data outside the instance, or
It's usually an attached volume.
it's an EBS kind of.
Yeah, exactly.
Okay.
So either EBS or Google, what is it called? Some volume only, but one of those technologies provided by the cloud. We usually use that. Again, like local on-prem deployments, it's a very risky thing. Like, but even there, it's like you have Ceph and you have some of these Kubernetes-based providers which are offering redundancy of the data. So it's a whole thing. But yeah, but even if that is the case, even if the state gets restored, you're able to rebuild it from the Kafka topics, right? Oh, the real time. Yeah. That will take some time. So that's okay. Insurance, yes. A lot of yeah. So no, we don't provide it like that. The insurance customers usually have their own data, and they collect these reports from hospitals. So the hospitals are sending the insurance data to them. They transform it and they do all of this. Yeah. So I think time is up. Next.
We're not data sellers at all. We don't own any of the data. By law in India, the hospitals are supposed to